Hello students, let us solve one problem on the load calculations and psychrometric processes. The question: an air conditioned auditorium is to be maintained at 27 degrees Celsius dBT and 60% relative humidity. The ambient condition is 40 degrees Celsius dBT and 30 degrees Celsius WBT. The total sensible heat load is 1 lakh kilojoule per hour and total latent heat load is 40,000 kilojoule per hour. 60% of the return air is recirculated and mixed with the 40% of makeup air after the cooling coil. The condition of air leaving the cooling coil is at 80 degrees Celsius. Determine room sensible heat factor, the condition of air entering the auditorium, the amount of makeup air, apparatus dew point and bypass factor of the cooling coil. So this is the question from Mumbai University, December 2023 paper. Now based on the condition given in the numerical, we have flow chart given here. So this is the auditorium that we have to maintain at drivable temperature 27 degrees Celsius and humidity 60%. The outside air is at condition 40 degrees Celsius dBT and wet bulb temperature 30 degrees Celsius. So based on the condition given in the problem, we have this flow chart and it is written in the problem that the amount of air is recirculated after the cooling coil and the coil temperature after the cooling coil is given as 18 degrees Celsius. So that data is given in the problem. Okay. So based on this, we have this flow chart. Let us now note down the given data given in the problem. So that is for I, that is the I am indicating I for the condition which is to be maintained in the auditorium. So TSI. So it should be actually TDI. So this is TDI, drivable temperature of inside condition. That is auditorium. So TDI is equal to 27 degrees Celsius and relative humidity is 60%. Then outside condition TDO is 40 degrees Celsius and wet bulb temperature TWO 30 degrees Celsius. The condition of coil, condition of air after the cooling coil. So TOC, I am indicating it by TOC. So TOC is equal to 18 degrees Celsius, so which I have mentioned as this point. Then the room sensible heat is 1 lakh kilojoule per hour. So if I convert this into kilowatt, so I get that as 27.28 kilowatt. Again, room latent heat given 40,000 kilojoule per hour. So in watt, in kilowatt it is 11.11. So as in the problem itself given in the numerical that the room sensible heat is there and room latent heat is there, and based on this data we have to find out the room sensible heat factor. Okay. So first thing that we can find out is room sensible heat factor, and we all know that it is the ratio of room sensible heat upon total room heat, that is addition of room sensible heat plus room latent heat. Okay. So if I note down the formula, so it is equal to room sensible heat factor equal to room sensible heat divided by room sensible heat plus room latent heat. So that data is with us. So that is 27.28, that is room sensible heat, and room latent heat is 11.11. So if I put these values in this formula, I get the room sensible heat factor as 0.711. Okay, 0.711, right? So first thing, that is a point we have calculated, so room sensible heat factor. Now next we have to find out the other parameters, that is condition of air entering the auditorium, amount of makeup air, apparatus dew point and bypass factor of the cooling coil. So before this, let us put or mark some points on the psychrometric chart and solve the problem. So based on the condition given in the numerical, so I have the drivable temperature of inside condition 27 degrees Celsius and relative humidity 60%. So based on this, I got this I point over here. Okay, let me, yes, this is the I point. You can see this is the 27 degrees Celsius drivable temperature and this line is of 60% relative humidity. So based on these conditions, I have this I point which is inside condition that I have to maintain. Next, outside air condition is also there, that is TDO 40 degrees Celsius and TWO 30 degrees Celsius. So this point, this line is of 40 degrees Celsius dBT and this line is of 30 degrees Celsius WBT. So those two lines are coinciding at one point, so that is O point. This is outside condition. So O is outside condition and I is inside condition. Now next we have to draw the room sensible heat factor line, and as we have room sensible heat factor value, it is near about 0.711. So on the sensible heat factor line we can mark the point which is this one. The value of that is what? 0.711. So this is, let us say, 1 point. Now I am drawing the line starting from this R point, that is the reference point, to the point which is I have marked over here. So this line is called as the reference line. So यहाँ पे जो yellow line दिख रहा है आपको, that is the reference line. Now parallel to this line, what I am doing is, I am parallel to this line, I am drawing a line starting from I point, that is the inside condition. So parallel to this yellow line, I am drawing one line, that is a red color line, starting from I point, which is nothing but the room sensible heat factor line. Okay, this is the room sensible heat factor line. Okay, how I am drawing the room sensible heat factor line? It is parallel to the line joining the reference point and the point which I have marked as a sensible heat factor on the sensible heat factor scale. Okay, the reference point, the temperature of this reference point is 26 degrees Celsius and 50% RH. So it is constant or same for all the numericals. So this is the reference point that I have to mark. Sometimes this reference point is given on the psychrometric chart, but it is not given. Then we have to consider that as a 26 degrees Celsius DBT and 50% RH. So this is what I have reference line, and this is the red color line is what? Room sensible heat factor line. Now after this one, as this the line on this line, room sensible heat factor line, actually we have 2 points. One is the temperature of air after the coil, and another condition which lie on this room sensible heat factor line is the supply condition. So these are plotted accordingly. So in this problem we have given the cooling coil temperature after, so air temperature after the cooling coil is given as 18 degrees Celsius. So what I am doing is, I am having the temperature, this is the line of 18 degrees Celsius temperature. So this point is on the red line, this point is on the red line, indicating that OC, because in the flow diagram itself we have the point outside the cooling coil is OC, that is 18 degrees Celsius, right? So 18 degrees Celsius, so I get the point OC over here, okay, which must lie on the room sensible heat factor line. Barabar hai? Next, now we draw a line from O to OC, okay, because on the cooling coil we have outside air, and after the outside air, after the cooling coil, we get the OC point. So the cooling coil or the air which is passed on the cooling coil is going into the auditorium. So this cooling coil has to handle the room latent heat, room sensible heat, also the outside total heat, that is nothing but the grand total heat. Okay, so cooling coil has to handle the grand total heat. So that's why we plot the line starting from O point and we join it up to the OC. So this is the line of grand sensible heat factor line, right? Now if I extend this line up to the saturation line, this point is on the saturation line, the temperature corresponding to this point is nothing but the apparatus dew point temperature, that is the coil temperature. So if I mark or if I check out the temperature here, so it is comes out to be near about 13 degrees Celsius. So if I write this based on the psychrometric chart, the apparatus dew point temperature ADP or coil temperature as 13 degrees Celsius. Okay, so that is the one parameter that we have to find out. Okay, so ADP we got as a 13 degrees Celsius. Now we got OC, we got ADP. Now next thing is that we have to find out the S, that is supply condition. What is the supply condition actually? Okay, what is the supply condition? Now if you refer the flow chart, if you refer the flow chart, this is supply condition indicated by the S point. We get the supply condition after mixing OC air and I air, that is return air and outside air after the cooling coil, so OC. After that we are getting this S point, right? So that means two streams are mixed together and we get the S condition. So in order to find out the S condition, we have to find out the temperature of that, and we have the formula to find out the temperature of mixed condition, like TS, that is the supply condition, MOC, that is the outside condition after the cooling coil, mass of the outside condition, and the temperature of that air. So temperature of air at OC, okay, plus MI, the air of second stream, that is return air only, right? So mass of that air multiplied by its temperature, so TDI, okay, TDI divided by MOC plus MI. So this is the formula to find out the temperature of mixed air condition when there are two streams. So OC is one stream and I is the another stream. Now in the problem itself given that the 60% of the return air is recirculated. That means return air जो भी आ रहा है, this is of 60%, and remaining जो आ जाएगा OC के जगह पे वो कितना परसेंट है, वो है 40%, right? So we can say that in fraction amount we can write this MOC as 0.6 because it's not actually 0.6, it is a 0.4, okay? Because the outside air is of 40%, so that's why we can write this as a 0.4%, okay, 0.4. And temperature of OC is given 18 degrees Celsius. I will write here, so 0.4 multiplied by 18 degrees Celsius plus MI, that is the mass of recirculated air. So I can write this as a 0.6 multiplied by its temperature, that is triable temperature. So it's a 27 degrees Celsius divided by 0.4 plus 0.6. So if I solve this, I get the supply condition as 23.4 degrees Celsius. So this way I can get the supply condition temperature, okay? So after knowing this value 23.4 as a supply condition, we can plot this on the line room sensible heat factor line. So how it is? If you see here, this point, this temperature is of 23 degrees Celsius and we have temperature 23.4. So just after this one, let us say this point I am following and I plot the point S point on the room sensible heat factor line, okay? So this is how we get the supply condition of the air, okay, supply condition of the air. Now next we have to find out this amount of makeup air. हमने क्या क्या निकाला है, हमने रूम सेंसिबिलिटी फैक्टर निकाला A, then we got the B, that is the supply condition. Now next we have to find out this, also we got the apparatus dew point also, it is 13 degrees Celsius, okay? Now next we have to find out the amount of makeup air. So let us do calculations for that. So C, we have to find out amount of makeup air. Now amount of makeup air, in order to find out the amount of makeup air, what is the amount of makeup air? Makeup air means how much amount of outside air we are allowing, okay? That means how much amount of outside air we are allowing on the cooling coil, and after the cooling coil same amount of air we are getting as a at point OC, okay? So in order to find out the mass of that amount of makeup air or fresh air or outside air, we know that it is 40% of total air, isn't it? It is 40% of total air. So in order to find out the mass of supply air, mass of makeup air, we have to find out the supply air first, okay? How much amount of supply air is, right? Now this supply air जो कि यहाँ पे है, this supply air has to handle the load inside the auditorium, that is room sensible heat and room latent heat. So this much amount of heat that supply air has to handle, right or not? So what we can say that we can say that room sensible heat plus room latent heat is equal to mass of supply air and enthalpy change of supply air. What is the supply air enthalpy and what inside the room is. Okay, so that we can write like this. So ms into enthalpy change is how much is enthalpy change, what is inside the auditorium, enthalpy of inside air minus enthalpy of supply air. So this way we can find out the mass of supply air. So ms equal to room sensible heat plus room latent heat divided by Hi minus Hs. So these two conditions RSH and RLH we know. Let us find out the Hi and Hs. So corresponding to I point we have enthalpy, which is on the written on the enthalpy scale. So it is near about the value is 61. If you go to the close to this line, this is of enthalpy 61. So Hi is 61, right? And Hs, so corresponding to S point, if you note down the value, it is near about the 56. Okay, it is near about 56. So this is corresponding to 56. So if I solve this now, I get the mass of supply air as room sensible heat is near about 27.28 plus room latent heat is 11.11. So it is 11.11. So divided by enthalpy of inlet air or inside condition, it is 61 minus the enthalpy of supply air, so that is 56. Okay, so if I solve this, I get the mass of supply air at S condition. Okay, at S condition, so it comes out to be equal to 7.678 kg per second. So this is the kg per second, mass of supply air kg per second. Now in order to find out the amount of makeup air, we know that the 40% of supply air is nothing but the makeup air. So amount of makeup air, so this is equal to 40%, so that is 0.4 of this ms, isn't it? So 0.4 into 7.678, so this comes out to be equal to 3.0712 kg per second. So this is the amount of makeup air. So that is point number D, I think. It's actually C that we have to find out, and D is what? ADP, apparatus dew point temperature. So on the psychrometric chart we got this value as 13 degrees Celsius. Now last point we have to find out is what? Bypass factor. Okay, bypass factor. So let's go on the psychrometric chart again. If you note here, this outside air is passing on the cooling coil, right? And at the exit we are getting OC, that is 18 degrees Celsius, right? And the coil temperature is ADP, apparatus dew point temperature, that is 13 degrees Celsius, right? Now if the bypass factor is 0, for example, let us say, then the outside air condition may be equal to the apparatus dew point temperature or cooling coil, right? But as some amount of air is bypassing the cooling coil, we are not getting the temperature at the exit equal to the coil temperature. We are getting more than that coil temperature. So that air which is comes out to the out of the coil is OC, 18 degrees Celsius, right? So let us say this is the ADP, or coil temperature, and this point is TO, that is outside temperature. So after passing on the cooling coil, we are getting less temperature. This is OC, okay, and this is again ADP, right or not? So if I say the bypass factor is 0, then at the exit of the coil we can get the temperature equal to ADP, but because of the bypass factor we are getting more than that, that is indicated by the OC. Okay, so after this one, bypass factor of the coil can be calculated as PBS equal to this temperature difference divided by this temperature difference. Okay, so we can write this as T of OC minus ADP divided by TO outside air temperature minus ADP. So by this one we can find out the bypass factor, how much amount of air is bypassing the coil. Barabar? So TOC, how much is the TOC? So TOC is equal to 18 degrees Celsius. The temperature of air after the coil, it is 18 degrees Celsius. The ADP is 13 degrees Celsius and outside air is how much? It is 40 degrees Celsius. So 40 minus 13. So if I calculate this one, I get the value of bypass factor as 0.185. 0.185. So this way we can find out the bypass factor, apparatus dew point temperature, amount of makeup air, the condition of air entering the auditorium, and room sensible heat factor. Along with this one we can find out the grand sensible heat factor also. Okay, so this way we can find out the problem. Thank you.